If anyone is watching this on video, I forgot to hit record at the beginning of the notes. So far, we're in the middle of example 1. You're finding an interval notation, where is the polynomial greater than 0? So you're looking at where is the graph above the x-axis. In interval notation. Yes. Great job. And as always, once you get it right, just check in with your teammates, make sure everyone's okay. Yes. Well done. So it doesn't hit at -2. This point here is -3, right? So it's -3, and then you have 4, but then it's still above the axis, so there's another part. It looks like there's a bracket on the 4. It should be a parentheses. Oh, so you don't need to 0 because like the 0 is like this, so it was like the stopping point kind of. This is like a yeah. This is like a okay.
Oh yeah. Wait, is it?
Oh, it's yeah. So they're actually where
You take this or this. What's the song today?
All right, ladies, everyone got it? Oh, here is the answer. So we have -3 to 4 and 4 to infinity. So, if you are given a polynomial and you're asked where is this greater than 0, where is this less than 0, where is this greater than or equal to 0, less than or equal to 0, this is basically how you want to do it. You want to glean whatever information you can from the polynomial, get an approximate graph, doesn't need to be perfect, you just need to see where is it above or below the x-axis, and then give interval notation for whatever they're asking for. Hi. Any questions on this one? Yeah. All right. Example number 2. Sorry, does anyone need more time to copy this down? Example number 2. Solve this graphically. This one we're going to do on a calculator. Let's see. I think the easiest way to do this is to first get 0 on the right side of your inequality. Does that make sense? Yeah. So get your polynomial in standard form and get 0 on the right side. So go ahead and do that. Excuse me. All right, was everyone able to get 0 on the right side? Okay, go ahead and graph it. Your graph should look something like this. And this is the window that I used for mine. Does everyone remember how to use the zero function? Okay, so if you need to, you are able to find all three of these zeros. Okay. Using that function, please tell me in interval notation where this polynomial is less than or equal to 0. So where is the polynomial less than or equal to 0? Round everything to 3 decimal places as needed. Yes. May I? I think you have your scatter plot on. Yeah. Just turn off your scatter plot. And if you want, you can reset this to L2. There you go. Thank you. So you need brackets. Oh, can I see again? Sorry. So I think you might have given me positive. So you want it less than or equal to 0, right? You're good. But the zeros are correct. Yes. Great job. So those are the zeros, but I'm looking for where is the polynomial less than or equal to 0. Yes. Yes. Good job. Guys, close. So you have the graph, right? Where is the graph below the x-axis? It's from negative infinity to the first 0, right? And then there's a gap. Sure. You guys got it? Brackets. Brackets on everything except the infinity. Great job. All right, here is the answer. Great job, ladies. Are there any questions? All right. Let's take a look at example number 3. It says, solve the equation algebraically, check for extraneous solutions. This is an Algebra 2 problem. Do you guys feel like you could solve it? Like, just straight out. Some people are looking like wincing. Okay. Do you guys feel like you could... Let's see here. If I gave you the first step, do you guys feel like you could take it from there? Okay. So the first step would be to factor this denominator. Once you factor that denominator, then you're going to try to get a common denominator on each side so you can cancel it out. Do you guys feel like you could take it from there? Yeah? Okay. Alright, so please solve this the rest of the way. Be sure to check for extraneous solutions. Does everyone know what extraneous solutions are? Those are solutions that when you plug them back in that you get something undefined or not true? Okay. All right, how's it coming? Are we getting stuck? Just need more time? More time? You guys feel like you're getting it though? Silence. Okay. All right. How about 2 more minutes and then we'll go over it. Okay. And if you're able to get it in that time, great. If not, don't worry about it. Yes. All right. We're going to go over it. It seems like you guys are making good progress, and I think if we had more time, you'd probably get it. Let's see where you guys left off. Was everyone able to eliminate the denominator? Okay. So you eliminate the denominator, and I also distributed the 2x here. I got 2x squared minus 6x plus x minus 1 equals 2. 2x squared minus 5x minus 3 equals 0. I subtracted the 2 and combined like terms. I factored. The 2 answers you get are negative 1/2 and 3, but if you remember, 3 produces a 0 in the denominator in our original equation. So 3 is an extraneous solution. Does that make sense? Yes. So what I do is I think of two numbers that multiply to give me 2x squared, and the numbers that multiply to give me negative 3, and then I just mentally FOIL over and over again until I get negative 5 in the middle. Now the other way you could do it is to split the middle term, which is what I teach. So I guess when I teach Algebra 1, I teach to split the middle term. When I teach Algebra 2, I usually teach to mentally FOIL over and over again. Either way works. Splitting the middle term takes a little longer, I think. Do you guys remember how to split the middle term, or is that something you've learned before? Split the middle term? Should I go over real quick? Yes. Okay. Okay, so let's imagine you've got, actually, let's choose this one. You've got 2x squared minus 5x minus 3 equals 0. So you're going to start with AC. AC is 3 times negative 6. Now we need to think of two numbers that multiply to give negative 6, but add to give negative 5. Anybody? Negative 6 and 1. So it doesn't matter where you put them. I'm going to put negative 6x here plus 1x here. And you can do this because negative 6x plus 1x is negative 5x. So I'm just splitting it into something bigger. And then you factor by grouping. I can pull out a 2x here, x minus 3. I can pull out a 1 here, x minus do it right, these will be the same. So as you can see, it's a little longer than just mentally toiling, but if you're having trouble thinking of what numbers will get that polynomial, then it's a good way to do it. All right, any questions on this? Does anyone need more time to copy this down? It's okay if you do, just let me know. All right. Okay, this one I think I might just do as an example. Did you guys learn sign charts in Algebra 2? It's usually taught towards the end of the year. Not at all. Okay, perfect. It's all good. We're going to learn them now. They did appear in a few of the AP Classroom videos, like early on. All right, example number 4. We have this, and we're going to solve this one algebraically without a calculator. Although you could also support it graphically. We'll solve it without a calculator, and then we'll graph it on a calculator just to check our work. Okay, so first thing I'm going to do is try to get this looking like a regular polynomial. So I'm going to try to get a common denominator. I'm going to multiply top and bottom by x minus 1, multiply top and bottom by x plus 3. Then I'm going to distribute the 5, distribute the 3. My denominator, I have this. When I do that, I have 5x minus 5 plus 3x plus 9. My denominator is still looking like that. So my numerator becomes 8x plus 4, and the denominator stays the same. I'm going to factor my numerator. So now my numerator and my denominator are factored. Okay, so the question is, where is this less than or equal to 0? And we are expected to solve this without a calculator. What we're going to do is we're going to make something called a sign chart. A sign chart is it's a collection of all the points where this could change sign. So you're going to make a list of all the zeros. In this case, there's only one zero, just negative 1/2. Are you guys all able to do that mentally? Get the 0 in the numerator? No? Yes? Maybe? Okay. So if you set this equal to 0, you end up with x equals negative 1/2. The vertical asymptotes are negative 3 and positive 1, and that's where the denominator equals 0. And there are no holes. These are the only points where the function could change sign. Okay, so these are the only places where the function could switch from positive to negative or negative to positive. So I'm going to put these numbers on a number line in order from least to greatest. So here we have negative 3, negative 1/2, and 1. And as you can see, it's in order from least to greatest. That's actually very important. Some people are wincing. Should I pause here, answer questions? Or back up a little bit? Or not? Yes?
How do you decide which signs go where?
So we're just looking at all the zeros, asymptotes, and holes. Take all those numbers, put them in order least to greatest on a number line. And then we haven't done the pluses and minuses yet. That's the last step. Yeah. But the number line's okay? Okay. So now, because these are the only places where this could either change from negative to positive or change from positive to negative, we just need to know, is the function positive or negative in between each of these values? So pick some number less than negative 3. Doesn't matter what. I think I picked negative 4, sure. And you don't actually have to plug it in. what you want to do is you want to mentally decide, if I was to plug in -5, am I going to get a positive value or a negative value for each of these factors? 4 is going to be positive no matter what you plug in. So if I plug in a -5, I'm going to get a negative on top. I'm going to get a negative here. I'm going to get a negative here. A negative times a negative is a positive, and a negative divided by a positive is negative. So the function is negative when it's less than -3. So from negative infinity to -3, the function is less than 0. Did that make sense? Okay, so then we're just going to do the same thing here. So from -1/2 to -3, I'm going to plug in -1. If I plug in -1 here, I'm going to get, let's see here, negative number here, positive number here, negative here. A positive times a negative is a negative. Negative divided by a negative is positive. So the function is positive here. From -1/2 to 1, 0. You can plug in 0. If you plug in 0, you get a positive number, and a negative number, which produces a negative number. If you plug in something bigger than 1, like 2, it's positive everywhere. Now, in this case, it alternates negative, positive, negative, positive. That's not always the case. If you have something with an even multiplicity, it's going to hit the x-axis and bounce back, so that's when you get negative, negative, or positive, positive. Yes?
So why, at the end, why do you factor ax?
You don't have to. It's a good idea to, in this case, you don't have to. It's a good idea to factor it completely just to make sure there's nothing in there that's going to impact the sign. In this case, pulling out the 4 did not impact any of the signs. But I would recommend doing it just in case, because sometimes you think it doesn't, but then when you actually start to do it, you realize that it has an impact on it.
I don't really understand.
Which part? So you're asking if it's necessary to pull out the 4, and I'm saying in this case, no, but in a different problem, maybe. I would recommend on these, factor it completely. If you're going to use a sign chart, you want to factor it completely. Yes?
I didn't understand this.
The sign chart. Okay. Did you understand making the number line?
Yeah.
Did you understand plugging in some number in between each of these numbers?
Yeah.
Okay. And you see that we're plugging it in here, right? I plugged in -4, but someone else shouted out -5. So if you mentally plug in -5, you don't have to solve it out. You just have to mentally solve it to the point where you see, is it going to be positive or is it going to be negative? If you plug in -5 here, you get -10 plus 1. -10 plus 1 is -9. -9 times 4 is -36. So on top, we're going to get a negative number. On bottom, if you plug in -5, it's going to be negative here and negative here. So if I have 2 negative numbers in my denominator, those are the 2 I have to multiply first. A negative times a negative, this is going to be positive. And then I divide negative number divided by positive number, which gives me an overall negative number. So that's what you do for each value, and that tells you whether it is, whether it's above or below the x-axis. Okay. All right, so do you guys feel like you could answer this question? Where is it less than or equal to 0? Based on the sign chart? You think so? Are there other questions I can answer before letting you guys try that? So this is saying that the function is below the x-axis, then it's above the x-axis, then it's below the x-axis, then it's above again. Yes? Good question. So in this case, it's underlined. So the zeros are going to be a bracket. The asymptotes are not. And the holes are not, if there are any holes. So in this case, zeros are included, asymptotes and holes are not. If it's not underlined, then none of them are included. All right, go ahead and give me interval notation. Tell me where the rational expression is less than or equal to 0. So the 0 is included, but the asymptote's not. Yes. 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 All right, everyone got it? Great job. Here is the answer. Okay, we have negative infinity to negative 3. There's an asymptote here, so it's not included. And then negative 1/2 to 1, this is a 0, so it's included. The 1 is another asymptote, so that is not included. All right, and if we were to graph this on a calculator, it would look something like this. So we have asymptotes at 1 and negative 3. We have a 0 at negative 1/2. And it's a rational function, so the lines are following in that way. Actually, you could probably graph this by hand based on the information we have. Yeah. I take it back. You actually don't need a calculator to graph this because you know that there's going to be a horizontal asymptote at 0, so these are going to follow here. You know positive, negative. Yeah, you actually don't need a calculator at all for this one. Do you guys feel like you could sketch this by hand without a calculator? Like, you know that there's a horizontal asymptote at 0, right? You know the vertical asymptotes are here and here. You know the 0's here. And then you know where it's positive or negative. And you know the basic shape of a rational function. What does 1 over x look like? It's like that, right? Right? Okay. So based on all that information, you could sketch something pretty close to the accurate graph without a calculator. All right. So really hoping to get to the activity. Let's do one more and call it. All right, if you guys turn the page. Oops, no. We are given this function, and they want to know The domain, the range, the horizontal and vertical asymptotes. In this case, because it's written like this, I actually think it's easier to use transformations. Like, you know that there's a vertical shift, you know there's a horizontal shift. Can you guys figure out the vertical and horizontal asymptotes from that information? Okay. Please give me the vertical and horizontal asymptote. If there are some. If there aren't any, just put none. All right. Yes, yes. All right. Any other answers? I apologize for rushing you guys. So you're going to want to give equations. I'll give it to you, but you're going to want to have like y equals this. Team 3, do you guys have it? No? No? Okay. Let's go over it. All right. So normally the horizontal and vertical asymptotes are at 0, 0, but because it's going up 5 and it's going to the right 3, the horizontal asymptotes are going to be at y equals 5 and x equals 3. So basically this graph is just shifted over. And that means the domain and range are these. Let me back up a little bit. Does that make sense? We'll do the rest of this activity not next class, but the class after. Next class, you guys have your test.
Pause and join me in ending the day prayer.
All right, great job today, guys.
In the name of the Father, and the Son, and the Holy Spirit. Amen. Merry Christmas.